Given the function f of x is equal to cosine of x minus x on the closed interval 0 to 4 pi, we're asked to use the second derivative test to find the relative extrema of f. So second derivative test for relative extrema is going to require both the first derivative and the second derivative. The first derivative, f prime of x, is going to be equal to minus sine x minus 1. Now cosine of x minus x, the domain is going to be all real numbers. Minus sine x minus 1 is going to be defined everywhere, so that says the original function is differentiable everywhere. So the only critical numbers we're going to find are when the first derivative is 0. So adding sine of x to both sides will give us sine of x is equal to negative 1 here. That's going to happen at 3 pi over 2, and is going to happen again 2 pi later, which is at 7 pi over 2. The second derivative, let me do that in a different color for you here, is going to look like negative cosine of x, and that's going to be it. So we're going to be interested in f double prime of 3 pi over 2 and f double prime of 7 pi over 2. Well, negative cosine of 3 pi over 2, that's going to be 0. And negative cosine of 7 pi over 2, that's also going to be 0. So the second derivative test ends up not telling us anything here. It was quick and easy to apply, but remember, when it's equal to 0, that doesn't mean anything. We're going to have to go to the first derivative test to try to figure out what's going on. So let's set up a sign chart here. I'm going to cap both ends at 0 and 4 pi, so I know where we're at. And then I'm going to apply 3 pi over 2 and 7 pi over 2. And then I'm going to convert these to decimals so it'll make finding test values a little bit easier. So 3 pi divided by 2 is about 4.7. And 7 pi divided by 2 is about 11. 4 pi, that's 11.0 actually. 4 pi is about 12.6. So some good test values along here. Therefore might be something like f prime, and we're back to the first derivative now, first derivative test. We're trying to figure out where the function is increasing and decreasing. So f prime of 4, f prime of 5, f prime of 12. Those are all nice values inside of each interval. I don't need these values to come out to nice values that we know in our head or we know from the unit circle. I only need to be able to plug them into the function and see what kind of sign we get from them. So if I take negative sine of 4, I've already made sure my calculator is in radian mode, so this will work. I get a negative value, which says we're decreasing. And if I take negative sine of 5 and subtract 1, looks like I also get a negative value, so I'm still decreasing. And if I take negative sine of 12 and subtract 1, I also get a negative value. So it looks like this function doesn't have any relative extrema, at least not on this interval. You should probably take a look at a graph and make sure that that makes sense. And you also want to make sure that you don't try to read into the fact that the second derivative test was inconclusive as meaning that the function wasn't going to have any relative extrema. Second derivative for some functions second derivative test, for some functions can be inconclusive, and yet we can still have relative extrema for the function. So don't overinterpret the second derivative test results when you get a 0. Just know that that means we need to go to the first derivative test to find out what's going on. In this case, we discovered that there weren't any relative extrema.